This is the water cycle, water's basic path in the environment. In this video, we will be going over how precipitation goes to the surface and then becomes runoff in a watershed drainage area.
Hey Alicia, that was some storm last night, huh? I heard it was like a 100-year event storm.
Yeah, it was insane. There was so much rain. Chaz and I live really close to a watershed outlet, so we were really worried about flooding.
Oh dang, that is pretty scary. But luckily in hydrology class, we learned about the rational equation, so you could calculate the peak discharge so you wouldn't have to worry about flooding.
That's very true. We learned that before Thanksgiving though, right? So how do you calculate that again?
This is the rational method. Q equals CIA. Q equals flow rate, and this is going to be in cubic feet per second. C is the runoff coefficient, and this is also the relationship between the impervious area, like parking lots or houses or the soil type with runoff. I is the average rainfall intensity of the area, and this is going to be in inches per hour. A is the watershed drainage area, and it's really important to remember that this equation is empirical, which means that the units don't cancel out because it's used in real-life applications. Once we understand the equation, we can figure out the info we need to calculate the peak flow.
In our lab examples, the runoff coefficient was changed based off impervious area and soil type. The intensity and area were kept constant in order to have one experimental variable, the runoff coefficient. This leads to changes in flow rate, Q.
Oh yeah, now I'm remembering all that stuff, so we should go down to the lab and simulate an example.
Heck yeah!
Woo!
In this simulation, there's a lot of impervious surface area in this watershed. This causes higher initial runoff and less infiltration.
Oh, so that makes a lot of sense. That was a lot of rain. So how would that change if there were no houses and the land was all natural vegetation?
Back to the lab.
In this simulation, there's no impervious surfaces. It's all sandy soil with high infiltration rates. If rain fell in an area with no impervious structures, like a forest or prairie, the rain would more easily infiltrate the ground and you'd have less runoff. That would change the impervious percent of the runoff coefficient.
That was a lot slower. I guess all of the houses and driveways really make a difference for the flow rate.